The Blue Deal Labs are aimed to create energy plants for the exploitment of energy from the sea. Our first trial was in Malta, but we could not obviously go there because of the COVID situation. This has required more effort from the partnership because the planning that is using blue energies requires many different skills, and all the partners of the partnership of Blue Deal have worked a lot in order to accomplish these results that you can see in the other videos. You can understand that this is very important for the future of the Mediterranean area if we want to really rely on also on blue energies for changing from this situation to a situation where fossil fuels are disposed and instead renewable energy are exploited. In this sense, we want to make a Blue Deal.
I think what we are going to see today is the result of the work of a Blue Deal team. First thing that can be done is to make an assessment based on climatological basis. Models can be of great help in assessing the power resource. The same thing happens for currents. For planning purposes and also for the operative maintenance of devices, we need data with a higher spatial and temporal resolution.
The process works like a sort of storytelling in which we analyze the blue energy potentials. The overlaying of these maps is combined with the technical and physical requirements of each technology, considering 6 different marine sources. The matching of this information provide a sort of first draft of blue energy mapping. We will at the end figure out how to implement a joint plan for portability that will be useful for replicability of this process anywhere in the Mediterranean area. What was very intriguing, very nice, was that every partner had its own role in the process, and based on its very specific competencies.
We classified it in 3 main groups: onshore, nearshore, and offshore technologies. We reported images, videos, and references with a brief explanation to better present the technology. For the oscillating water column, in this case, we base our assumption on 2 main operating devices, one in Spain and one in Italy. So we collected and reported all the useful information regarding physical and technical requirements to allow a correct planning process. Here we show a range of dimension of the device and also a range of electricity production. 100 meter per plant in this case can have an installed capacity of 60 kilowatt and supply energy for around 100 households. Another interesting onshore solution could be the onshore floater.
After that, we analyzed the offshore marine energy converters. The first solution is oscillating buoy, a system able to exploit wave energy through a floating body connected to self-orienting moorings and a piston and a cylinder mechanism to generate electricity.
We first put together this geographic information system from open access datasets and all the information our colleagues from INEA, INDACO, INISI gave us. And then for the specifications and needs of each one of the blue energy technologies, we made a selection of compatible areas, and then we excluded those areas which were not suitable at all. This method is meant to be both a tool for decision making and for facilitating a dialogue with stakeholders during the labs. As you can see, There are plenty of options for blue energy deployment. We have heat exchangers, oscillating attenuators, oscillating water columns, onshore floaters, offshore buoys, rivers, electrodialysis, offshore floating wind, and marine biomass.
What I would try to deliver here is to try to capture the needs of the audience, of the lab participants, in order to devise visualization of the environment in which the blue energy technologies are called upon to operate, and provide elements of animation and gamification. The exercise here has to do with four models that present the most technological maturity in a sense. They have been designed from scratch. We can play around with the navigation. Also, all the information is going to be presented there. You can download the model as well, or screens, or the designs if you wish. We have to engage again with the technical partners to see how to present a more accurate visualization when it comes to the energy generation and how this energy is distributed, what could be the implications for the environment, for example. When it comes to the actual pilots, we have selected two pilots that have been prepared by our partners here. This is the actual DTM, I think, is the actual elevation model of this specific area. This is really close to the Malta harbor, away from the navigational lines, and really close to the shore. This is a 167,000 square meter area that we can place these specific buoys. We can also visualize the number and according to the design. So if the participants or the mayor of the government decides to go for 200 of those generators, we can have them put in place and their support structures as well.
The result of this exercise was first a time series of wind speed. On the upper left, you can see two representative time series. There are almost 10 days of data. One is for winter period and one is from the summer.
First we need to do was background analysis and input data sources. It was several documents which we used as a reference case. The most important one was the National Renewable Action Plan developed by the government of Malta and the Maltese 2030 National Energy and Climate Plan. These two curves which you can see are obtained from EMEA and CRES. I mean, they send us the data and we build up the curves based on this data. Both of these distributions are built as an average of 3 different locations. Electricity production from wave energy converter is really low. Even if we consider 50 megawatts, which is unfeasible with current technology readiness, and which is not feasible even with geographical and other boundaries if we take account. In case that this electricity mix is simulated on yearly basis, you can see the electricity production from each sources, and you can see that existing power plant on natural gas is dominant. It should be mentioned that photovoltaic has better potential for case of the Malta, since the annual installed capacities are around 20 megawatts, and it will most probably be and remain the second most important energy source on the island, with again power plant on natural gas as the main source. Offshore wind could be installed and has potential in future, but for the wave energy, this is really at this point quite low, but I will go back to this at the end. Blue energy have limited potential for considered area. Greatest potential is observed for offshore wind, as expected, and this is also important due to the fact that the technology readiness for this energy source is on higher scale, and it will be deployed on commercial scale in probably some short to medium term. Wave energy potential at this moment, this potential is quite low.
The different types of receptors that could be affected by a marine renewable energy project is the benthos, fish, marine mammals, seabirds, water, air, and the marine habitats. these are some tips on how to actually identify the environmental effects on these different species. So they arise because a marine renewable energy device modifies the hydrodynamics, sediment dynamics, the seabed, the quality of marine waters, and the marine acoustic environment. By doing these modifications, you can end up in having increased turbulence in the water column, turbidity, chemical pollution, noise pollution, increase in electromagnetism, and habitat disruption. And all of these can impact aquatic species either through changing their behavior, so communication between them, navigation, reproduction, etc., or can even actually cause damage to them, physical damage, or even death from collision with devices and chemicals, etc. So because we have said many times that there is a lack of data, and there is, I have put a list here of some of the sources of data that could help, particularly with the aquatic species issues. I also would like to point out that for an environmental impact assessment, a lot of these legislation that I've mentioned are a good guidance, because you need to meet them and show that you have met them in your environmental impact assessment reports. And actually, a lot of the topics in here and the guidance in here in these separate legislations can actually help you very much, both with the baseline monitoring, but also with the identification of effects and identification of different types of measures for reducing the impact.
Last week, we were talking about the Open Innovation Challenge that it's going to be held during this project. Let me remind you that the Open Innovation Strategy, in a context of open innovation, the most established companies or entities, ports, hotels, etc., will interact with the entrepreneurial ecosystem and the researchers and advance their challenges. The Open Innovation Strategy from the Blue Deal project will promote the efficient matching of demand and supply of innovation and knowledge-based services in the blue energy sector. Let me just show you what are the 3 items that should be filled in, for example, okay? If you are the challenge sender, then we are talking about 2 things, okay? In red, you will see the challenge description and the video recording, okay? It's very simple. The challenge description is not a big report or something. We are talking about half a page with the context, the description of the company or entity who is proposing this challenge, the description of the challenge, and the problem definition.
We will try to find a way how to combine all this knowledge with a major event that we are organizing this year, and it's called Circle the Med. Actually, the Blue Deal Business Forum is going to be incorporated in the event. When it comes to the stakeholders that are going to be invited, we are aiming for the SMEs, we are aiming for enterprises, we are aiming in organizations involved in the value chain of the blue energy economy. The stakeholders will exhibit their technologies. This is the main aim. The idea is to create synergies among the invited stakeholders and the Blue Deal partnership. We're going to be able to give some idea on what's happening on funding and financing opportunities in the field of blue energy. We are thinking of creating a blue agora that can be hosted B2B, B2B individual meetings. Participants will have the ability to book some slots.
What I would like to do today is to show you live what is the platform that we created, we developed in Pelagos, and it's really a very useful online platform that could be the basis for support our activities too, as also it is foreseen in the work program of Blue Deal project. The very interesting thing is that on the technology, this part of the platform technology, we have very good information about technological products that are of interest.